everyone. This is our lesson on speed and velocity. So by the end of this lesson, I hope you can compare velocity, speed, and momentum using investigations, graphing, scalar quantities, and vector quantities. So let's first start with speed. So speed is the change in position, a rate of change in position, and it's how fast something goes or how slow something goes. The rate is any change over some time interval between two different quantities. So for us, it's going to be distance in comparison to time. And this is also known as the rate of motion. There are three different types of speed that we'll look at a little bit here. And that's instantaneous speed, which is the rate of motion at any given point. So this is not over a time interval. This is at 60 seconds or at 5 minutes. We've got a constant speed, which is the rate of motion that does not change. So that means the distance covered in an amount of time does not change. So I like to tell people constant speed should be like autopilot in your car. And then average speed is the total distance traveled divided by the total time, which is normally what we'll calculate. So then when we calculate speed, it is distance divided by time. So you can see our calculation here. So you can look at our calculation d over t. So let's look at this example problem and go through it together, and then you have one to do. Try that one. If you have questions, you can ask me in class. So this says a sprinter can run 100 meters in 10 seconds. Find the speed of the sprinter. So we do not know the speed. We do know the distance traveled was 100 meters, and he was able or she was able to do this in 10 seconds. So we're going to do distance divided by time, which is 100 meters divided by 10 seconds. Very easy. And the speed would be 10 meters per second. So please do not forget your unit here. You have to have meters per second or whatever measurement units you have at the end. So now you go ahead and you try this example, pause the video and try it, and then you can come and ask me if you have any questions. All right, so now let's talk quickly about graphing speed. So we would use a distance versus time graph. Our x-axis is going to be the time. Our y-axis is going to be the distance. So our vertical axis will be the distance that we travel. The x-axis is going to be the time, the horizontal axis. So here's just a quick example to show you what these would look like. So if we have a positive slope, that means whatever object it is speeding up. So this is average speed. Okay, if the line is 0, that's a constant speed. So we are not changing that distance over time. It's staying very regulated. And then if we have a negative slope, that means your object is slowing down. So now let's talk about velocity. And velocity describes both speed and direction of an object. So this is just like speed, but now we have to add that direction component. For two objects that have the same velocity, they must be moving at the same speed. So that's the first thing. And in the same direction. So for them to have the same velocity. So you could have two objects moving at 5 miles per hour, but if one's moving north and one's moving east, they don't have the same velocity because their direction is different. So to calculate velocity, you would solve it exactly like speed, but you have to put that direction component at the end. So like 5 miles per hour north. And when you graph velocity, it's similar. So it's just like a speed graph where your time now is the x-axis still. The velocity would be the y-axis. And then you would just plot the appropriate points based on whatever question you have. So here's how you would calculate velocity. So you can see that. We've got instantaneous velocity, again, would be at an instant. Average is over time.